Welcome back to my channel. In this video we are going to visualize the solution for this daily temperatures DSA question. First we are going to visualize the solution and then we are going to code our visualization in Leetcode. So let's get started. The given problem description says that we have an array of integers where each element represents the temperature of that particular day. Suppose at 0 the daily temperature is 73. Now we have to find after how many days we have to wait to get higher temperature than 73. So we can clearly see if we will wait for one day, then we will get higher temperature than 73. That is why in the output 1 has been written. Now from 74, how many days we have to wait? We can see only one day we have to wait. That is why 1 has been written. In the second day, how many days we have to wait to get higher temperature than this 75? We can see this is smaller than 75, this is also smaller than 75, this is also smaller than 75 and this is the largest one. So after 4 days to get higher temperature than 75. Brute force way to solve this problem is you can take 2 pointer as current and next and you can move this next as long as you don't get most recent higher temperature till the end of the array, and then you can update your next and again you have to move your next pointer until you don't get the most recent higher temperature. The problem with brute force solution is with the time complexity. It takes order of n square as the time complexity. So the question is, can we optimize this solution? If you will observe this brute force solution carefully, then you will find that we are again and again checking whether this element is greater or not. Instead, what if we had some memory in which we can store that this is the greater element and it could be the greater for someone else also. Then you have come up till here that we can store something in the memory, then why not think of a stack memory? Yes, we can use stack memory to solve this problem in linear time complexity and I will show you how. Now let us introduce the stack memory into our solution. So currently we are standing at day 0 and we want to know after how many days we have to wait to get higher temperature than this particular day's temperature. So currently this is impossible to tell because if you want to tell, then you have to visit that element at least one time. So which we are already doing in our brute force solution. So instead what you can do, not starting with the day 0, you can directly go to day 7 and start from it. So you can see that from this last day we don't have any day further. That means there are no any day which has higher temperature than this. So we can assume that this is most recent higher temperature that we have got till now and we can push this day into our stack. Since we don't have any of the day which has higher temperature with this particular day, so the answer to this is 0 and then we can move our current. We want that this current should always be less than the top of our stack. You can see in our top of our stack it is 73. That means our assumption was wrong. This is not the most recent higher temperature that we have got till now. The most recent higher temperature is this one. So what we can do, we can pop this element from the stack and we can push this as the most recent higher temperature till now. And you can see till now also we do not get any higher temperature than this 76. So answer to this element is also 0. And then you can move your current here. What we want is our current should always be less than or equal to the top of our stack. You can see in the top of our stack the element is 76 and we can clearly see that 72 is less than 76. That means what we can do in this situation, we can do day 6 minus d5 which is 1, which is what we can store in our array. And then we will also push this 72 into our stack because we can assume that this 72 can also be the most recent higher temperature for someone else in future. And then we will move our current. We want that this current should always be less than the top of the stack. Yes, it is. So what we can do d5 minus d4 which is 1. So we can write that 1 into our answer. We can assume that this could be also the most recent higher temperature for some other element in future. And then we will move our current like this. Now we want that this current should always be less than the top of the stack. But you can see 71 is not less than 61. So our assumption becomes wrong that this element is not the most recent higher temperature. So we can pop this element from our stack and then we have to compare with this element. Now the top of the element is 72 and we have to compare from here. What we want is this current should always be less than this top of the stack. And you can see that 71 is less than 72. So what we can do d5 minus d3, which is 2. That is what we can write in our answer. And then we will push this 71, assuming that this could be the most recent higher temperature for some other element in future. And then we will move our current like this. Now we want that this current should always be less than the top of the stack. But you can see that it is not. So our assumption again becomes wrong. This is not the most recent higher temperature. We can pop this element from the stack and then we will compare with this particular element. We can compare this 75 should be less than this 72. No, it is not. So we can pop this element from our stack and then we will compare this 75 should be less than this 76. And yes, it is. So what we can do day 6 minus day 2, which is 4. That is what we can write in our answer. And then we'll push this element into our stack, assuming that this could be the most recent higher temperature for some of the element in future. And then we will move our current. We want that this current should always be less than the top of our stack. We can see that 74 is less than 75. So what we can do day 2 minus day 1 is 1. That is what we can write in our answer. And we can push this element to our stack, assuming that it could be the most recent higher temperature for some of the element in future. And then we can move our current. Now we want that this current should be always be less than the top of the stack. We can say yes, it is. So what we can do day 1 minus day 0, which is 1. That is what we can write. We can push this element to our stack, assuming that this could be the most recent higher temperature for some of the element in future. So we will move again, and since there are no more further days are left, we will break it from our loop. If you have understood this explanation, then I highly recommend you to write the code by yourself. But if you are struggling somewhere, then now it's time to code our visualization. Now in Leetcode, we have this variable temperatures, which is the array of this element. I'm just renaming the variable as temp from our visualization. So what we know is we want a stack. So we will create one stack like this. I'm also taking one answer array, which we can return at the end. Now we will run a for loop. Now remember, we are running the for loop in reverse manner. So we will take I is equal to temp.length minus 1. I should be greater than or equal to 0 and I minus minus. Through our visualization, what I remembered is every time we have to push the element, the index of the element towards stack. So what we can write is st.push. I am pushing the index of the element. But before that, we want to check something. We will check while our temp of I is greater than or equal to top of our stack. So this particular thing will give us the element which is present in the top of our stack. If this statement is true, we can pop that element from our stack. That means this is not the most recent higher temperature. But always remember that if you are dealing with pop, then it is very necessary you first check is there something present in our stack. To check that, we can do, if the stack is not empty, we can pop the element from our stack. If stack is not empty, then we can write answer of I is equal to the top of our stack, which is st of st.length minus 1 minus I, and else we can write answer of I is equals to 0, and then we can return our answer. Let us run this code. So all the test cases are getting fast. We can submit it. So the time complexity is order of n. we are iterating all over the element only one time, and space complexity is also order of n.